Okay, hi, grade nines. All right, we carry on. This time I've now moved ahead one page here. I think this is 328. Yeah, I'm just going to go 328. Okay, this is similar to the last question, so I'm going to spend less time on it. And I say that because the only real difference here is instead of dealing with perimeter, we're now talking about the area of rectangle A equaling the area of rectangle B. And we know that the area for any given rectangle, okay, whatever letters you prefer, the area of any given rectangle, that's my symbol for given rectangle, whatever size, whatever shape, is going to be base times height. Or in my day, in the old-fashioned days of horse and buggy and churning your own butter, length times width. Regardless, the relationship is based on multiplying the two dimensions, okay? I don't care what you call them. So, and it says here, again, I didn't repeat the instructions because the instructions are the same for my fake question. They have equal areas, all right? So think about it. Like you could have a long, skinny rectangle. What if it was 12 by 1? The area is 12. 12 times 1 is 12. What if you had it almost looking squarish? What if it was 4 by 3? It's 12. So let's not be surprised that rectangles could have, even though they look different and they could look completely different, they could have theoretically the same area, okay? It's really just a multiplication thing. Think of all the ways you could factor the number 24. You could have a 2 by 12 triangle. You could have an 8 by 3 triangle. You could have a 24 by 1 triangle. You could have a 6 by 4. Okay. Having said all that, let's get into it. Let's call this one A and B because I didn't really label it. But basically we have this. We have this side here, if we want to call it a base, and here is your height. Now, it's 2.4, so I guess one of the skills they want you to practice on this question is the distributive property, because there's your base, but your height is a complex expression. In other words, it's not just a simple number. This is not a 12 by 2 rectangle where you just multiply two numbers, right? You've got a number times an expression. So it automatically implies, grade nines, that you're going to need some distributive property here, okay? All right, so I'm just going to get that letter B out of the way. And then over here, you've got the area of B, okay? The area of B. So the area of B is equal to, again, start with your constant or your uncomplicated expression. Here we started with 2.4. Here we're going to start with 4 outside the brackets. And we're going to multiply that by its base. So the base in this case is m plus 5.2. So in other words, this was a clever way of setting up a double distributive property where you have a distributive property on the left and you have a distributive property on the right, okay? All right, let's hack away at this thing. All right, so you're going to distribute the 2.4 through here. 2.4 times 3 is 7.2m. 2.4 times 2 is a positive 4.8. Okay, let's distribute the 4 through here. Remember, of course, this is just a single 1m. 4 times 1m is 4m. And 4 times 5.2 is, well, 4.5 is 20, plus 2 is 0.8, so 20.8. Okay. Now, I was talking about a little hack earlier. I noticed that both, in terms of our m's, we have a positive 7.2 and a positive 4. I think I'll subtract 4m from both sides. Okay, because guess what happens over here? I'm left with a positive, and I suppose I could have wrote this a little bit better, right, grade nines? I could have acknowledged that 4 is the same as 4.0. Line up our decimals to be nice and neat about it, Mr. Smith. So, wonderful little zero pair out there. 7 minus 4 is 3.2m. Now, if I went all the way the trouble to bring the m's over to the left side here, that means I better get rid of this 4.8. Okay, and I better bring it over here. So the way to do that is to subtract 4.8 from both sides. Okay, again, nice little effect there of zero pairing itself out of existence. And 8 minus 8 is 0, and so this is just 16. Okay, cool. All right, so what do we have here? What are our leftovers? We have 3.2m is equal to 16. All right? 3.2m is equal to 16. What are we going to do to both sides? Well, let's divide by 3.2. Let's see what happens. Okay? That does not cancel to 0. That reduces to a 1m. Okay? And 16 divided by 3.2. I know if it was 32, it'd be half. So 3.2 should be 10 times more. It should probably be 20. 16 divided by 3.2 equals 5. Sorry, 5, not 20. What am I talking about? Sorry, I was out to lunch there. I was reversing. I was thinking of 32 divided by 16, not the reverse. So m is equal to 5. Could we check this? Yes, we absolutely could. Let's do this color. So we're saying the m is supposed to be a 5. And the m here, because there's a multiplying relationship, we better write some brackets in. So check this out. 3 times 5 is 15. 15 plus 2. So let me write it over here because this side here equals this side. So this side is 17. Well, what is 17 times 2.4? Okay, let's bring that over. 17, clear that. 17 times 2.4. 40.8. 40.8. Now over here, we've got 5 plus 5.2, right? Which is equal to 10.2. So this side, 10.2 times 4. Right? So 10.2 times 4. Ooh, I think I'm going to be happy here. 4 times 2 is 8. 4 times 0 is 0. 4 times... Look at that. We're happy. So the area equals the area. Same question here. Okay, grade 9s? All right. See you later. We'll see you on the next go-round there, the next question.